This video is all about the mechanical properties of a concrete. Now, a concrete has a height of 5 meters and has a unit area of 3 meters squared, supports a mass of 30,000 kilograms. Now, we are going to determine first the stress, followed by the strain, and lastly, the change in length of the concrete. For this example only, we're going to use the acceleration due to gravity as 10 meters per second squared. The Young's modulus of the concrete is 20 times 10 raised to 9 Newton per meter squared. Now, let's define the given parameters. The Young's modulus of concrete is 20 times 10 raised to 9 Newton per meter squared. The initial height, LO, is 5 meters. The unit area, A, is 3 meters squared. And we have the weight. Solving for the weights of the whole system, okay, this gives us W is equal to mass times gravity. Okay, this is 30,000 times 10 gives us 300,000 newtons. Okay, this is the force or weight which is carried by the concrete. Now, we are required to determine the stress for letter A, B for the strain, and letter C, delta LO or delta L. Okay. Now let's proceed with the solution for the stress. Stress is force per unit area. So this is 300,000 newtons all over 3 meters squared, or simply our value of the stress is 100,000 newton per meter squared, or in scientific notation, this is 1 times 10 raised to 5 newton per meter squared, or pascals. Now for letter B, if we're going to solve for the strain, remember, we are given with the Young's modulus of the concrete, and we already solved for the stress. So solving now for the strain, we're going to use the formula E is equal to stress all over strain, or Young's modulus is equal to stress all over strain. And manipulating the whole formula, this gives us strain is equal to stress all over Young's modulus. Plugging in the values gives us our stress at 1 times 10 raised to 5 pascals all over our Young's modulus 20 times 10 raised to 9 pascals, or if the units cancel out, this gives us our strain, if we're going to simplify this, at 0.05 times 10 raised to negative 4, or simply 5 times 10 raised to negative 6. Now, our strain is always unitless. For letter C, the change in length or height of the concrete, strain is equal to delta L all over LO, or change in length all over the original length, and manipulating the whole formula, getting now our change in height or length of the concrete, delta L is equal to strain multiplied with the original length. Plugging in the values gives us delta L is equal to 5 times 10 raised to negative 6 times 5 meters, or simply the change in length after supporting the mass of 30,000 kilograms gives us 25 times 10 raised to negative 6 meter.